Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great event on tap today, including a demo. I'm so excited about that. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can before the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is vulnerability assessment using Datadog and Snyk. Our speakers today are Liran Tal, who is a senior developer advocate at Snyk. Hi, Liran, how are you? Thanks for joining me.
Thank you, I'm good. Thank you for having us.
Good. And Andrew Krug, who is the technology evangelist at Datadog. Andrew, thank you for joining me. Good to see you.
Hi there, thanks for having me.
All right. Well, I know, Andrew, you're going to be kicking us off. I'm going to take myself off camera and put myself on mute and let you get right to it.
All right, thanks, Charlene. All right, so like Charlene said, this is vulnerability assessment using Datadog and Snyk. We've got a great lineup of content here for you today. Just beyond kind of the intros, we're going to talk a lot about vulnerability management and kind of some of the challenges around that in general. We're going to talk about why Snyk and Datadog are partnering at all, and we're going to understand how that partnership works. It leverages our continuous profiler and some of the cool things that Snyk has for mapping vulnerability information to profiles and traces. And then we're gonna kind of end things with a demo, but I think the main point of this is that this is an interactive webinar. So if you want to ask questions, definitely put them in the chat channel. We love to see engagement in the chat channel, just to know, you're kind of still with us, that you're watching, that you either are enjoying or not enjoying the content. Regardless of your feedback, definitely let us know. And Charlene will surface that via the chat, and we'll wrap things up with kind of an open question and answer, and it doesn't have to necessarily be even related to what we showed you. If you have general questions about Snyk or Datadog, there is no question that is a incorrect question to ask. With that, like Charlene said, I'm Andrew Krug. I am a technical evangelist at Datadog. I am one of many technical evangelists at Datadog, not the only one. So you'll see many of my colleagues around presenting at various conferences. And I'll go ahead and let Liran introduce himself again.
Hey everyone, Andrew, thanks for all the intro and getting us up to speed here. I'm from Israel. I'm a developer advocate at Snyk. We're going to talk to you about how we're making developer-first security platforms work, and I think we're gonna jump right through it, right?
Yeah, we're gonna kick things off with why we decided to partner Snyk and Datadog's technology to solve this specific problem. So I think what's really unique about our partnership, right, Liran, is that we couldn't really do this kind of vulnerability assessment without each other's respective technology.
Yep, totally agree there.
Snyk has the vulnerability metadata, and Datadog has our continuous profiler. In this case today, we're going to be looking at continuous profiling on the JVM. And the combination of those two technologies lets us deliver what I would consider the type of user experience for vulnerability assessment and triage that I've never seen before. And that's very, very cool. But I think it's even cooler that this is available in a Datadog trial and the Snyk free tier. So you can kind of get started with this and you can try it out, anything that you see today, without having to put a credit card in anywhere.
Yeah, definitely. I like the fact that basically with this integration, I mean, if you went up till today, you went into the Datadog dashboard and you were looking at profiling application, understanding why a function, takes time, why it's running slow, is it CPU clocks, is it a memory footprint? But basically now with this integration, you can also find out that calling this function actually means calling vulnerable code. And you can see that based on real application behavior. So we're essentially bringing software composition analysis into the runtime with this kind of integration. So excited to see the demo today, Andrew.
Yeah, it's going to be very, very cool. And don't worry if you haven't used continuous profiling or you're not a security engineer, because we're going to bring these two things together in a way that's extra easy and kind of builds on some of the popular themes from the year in security overall, right? Things like shift left and detection and response. So I think you'll be able to kind of see how this relates here in just a bit. But first, let's just kind of define what we mean when we say continuous profiling, right? Because that's a couple of words that might mean different things to different people. So in the case of our example environment that we're going to be looking at today, we're going to be using the Datadog continuous profiler on top of the JVM, which is different than tracing, right? So we have our APM product family. It has tracing information in it, but it also has the ability to do this kind of continuous profiling. And the primary difference between the two, or at least the way I like to think about it, is that one is related to things that the app is calling out to, like HTTP services, APIs, etc., and how long it takes the application to go do that. That's what my brain defines as tracing. But profiling is our ability to actually look inside the Java virtual machine itself and instrument the method calls that are running on the JVM, the actual bytecode itself, and look at how that bytecode is interacting with the operating system. Is there anything I missed there, Laurent?
And that's exactly answering. I had this question on what is the difference between profiling and tracing, and that's right in there. So what basically are we seeing here? What are the profile types that exist here?
Yeah, so on screen here, you're sort of seeing the architecture diagram, but I'm going to in the next slide, which we can just go to now. On the left here, we have a profile, and I know it might be kind of hard to see, and I think we're going to find a way to get the slides out in the email after this. So if this is hard to see, you'll be able to kind of blow it up. But on the left here, you have a Java profile, and on the right, you have a trace. So you can see that the graphs look very, very similar. But on the left, if you look down there, you can actually see that the methods that are being called, like there's a garbage collector in there, for example, you're seeing the actual number of milliseconds it took to execute that call. Where in the profiling graph on the right, we're actually seeing the amount of time it took to do an HTTP GET, for example. And I called it a profile, but that's a trace, and it's request oriented. So I like to think of that as how long did it take to perform this MySQL query, where a profile might help you with how long did this while loop that has a thread pool of a certain size take to execute. And as a security engineer, these aren't things in my past I've really looked at a lot when I think about vulnerability data, but there's a very cool way to kind of tie these things together if we can just kind of understand a little bit more about how the application's actually executing code, what methods are being called, and what the dependencies are that underlie the app. But that's going to all be on the profiling side of things. And with that, I think it's time for our first poll. So Charlene's going to come back, and we're going to ask for a little audience participation here.
Yes, I'm just pulling up the poll and sending it out to everybody now. It should be on your screen. The polling question is, what language do you develop in the most? You can choose from Python, Java, JavaScript, Rust, or Go. Go ahead and make your selection. And while the audience is doing that, just a quick reminder that We are going to be having a question and answer period near the end of today's webinar. So if you have a question for either Laron or Andrew, please go ahead and use your GoToWebinar control panel. You don't have to wait for the question and answer period to submit those questions. So you can do that anytime. So if you do have a question, like I said, we'll probably take about 5 or 10 minutes near the end of the webinar and go through those audience questions. Excuse me. Okay, we are, excuse me, coming up on a minute here. So I'll give you the audience about 5 seconds longer to go ahead and make their selection, and then we'll take a look at the results. All right, I'm closing the poll out now. And here are the results for you. What language do you develop in the most? Python is the most popular, guys, followed by JavaScript. What do you guys think of those results?
It's interesting. I think very much kind of putting the perspective of the rise of open source software, similar approach from what GitHub is sharing and so on, the state of the Octoverse saying. Yeah. What do you think, Andrew?
Yeah, kind of unsurprising from a results perspective. I think Python, in many of the surveys I read, is just kind of like overtaken everything as the most popular language. I'm surprised that we don't have any Rust developers, though.
Yeah, I was going to say that.
With the rise of Rust, because Rust is in so many things. It's on spaceships, you know. So there's
JavaScript too, but I don't know if I'm happy about it or concerned about it now.
Yeah, that is a different webinar.
All right, well, I'll hide these results and let you guys get back to your program, your presentation.
Sure thing. Thanks for the participation for the from the folks who filled out the poll. That kind of helps us understand who we're talking to, right, as an audience, since the majority of this is Java focused. And I don't actually come from a deep Java development background, but it was really fun to actually build this little demo that we're going to show you, right? And so I'm just going to switch real quick and walk you through kind of this sample app that Laron and I were able to put together in a very short period of time using the Snyk and Datadog tooling. So we have a sample app that we call the Java Goof app. It's just it's a to-do list implemented on top of the Struts framework. And you might be able to remember a famous data breach that was the result of a vulnerability in the Struts framework. If you can remember, if anyone thinks of which one that was or knows which one it was, feel free to put that in the chat. But we're gonna leverage that same vulnerability in the Struts framework today. And so the code is also all available on GitHub now. So anything that we show, you can just go look up on GitHub. We'll have links as well at the end of the slide deck for you to go and kind of browse that. So this is just a simple Docker container. In my case, I was deploying this using the AWS CDK, which is AWS's way to describe infrastructure using code, either TypeScript or Python. So I built the deployment for this using AWS Fargate and Python to do the infrastructure as code portion. The Docker file is very, very simple because we just have this Java app that runs using Tomcat and Maven for the build pipeline. And then we form it all using the AWS CDK and then push that up to AWS Fargate. The most important thing on this screen here is that we have to add Datadog's Java agent profiler. And this is just a Java jar file that's provided by Datadog. It's 100% open source, as is much of the I think all of the things that touch a customer system at Datadog are open source. So you can go and see exactly how that works if you want to. But what this jar file does, and you'll see it in a subsequent slide as well, is it allows us to get traces from the regular Java JVM flight recorder and ensure that those are shipped off to Datadog. So if you're a visual person, this is what the app architecture actually looks like. We just have a simple load balancer and a single Docker container running in Fargate that's running the Java app. And then we're actually running the Datadog Sidecar container pattern as well, which if you're a container person, this is just a 2-container deployment where one container binds a port to another container. And that's what we use as the means by which we exchange telemetry between the Java app and Datadog itself.
Interesting, that sidecar thing. I guess we're going to get back to why that happens, right?
Yeah. So
as a hand cliffer for a sec until we get there.
Yeah, we're gonna run an exploit in just a minute here. So if you're thinking of dropping off, just hang on, stay with me. There's gonna be some real actual exploits that we're gonna fire here. But the sidecar pattern is very, very cool for a lot of reasons. The most notable of which is that we Datadog manage the container actually for you. So that's just one less thing that you kind of have to build as part of your environment. So let's go look at the app real quick. So we should be seeing the actual Java Goof app itself right now. So this is the app as it exists on GitHub. This is the this is the file of code that is the CDK code that actually goes and forms that infrastructure in AWS Fargate. It's really, really small. It only has these two tiny containers in here, so really not much there as far as the infrastructure as code. And the rest of it is just plain old Java app. So you can kind of see the pom.xml file if you're familiar with Maven builds. Here's the actual app itself. So you can see that it does in fact, it is a functional real app that we're going to show you today. And then we're going to exploit it. So there are a number of exploits that are actually available for this version of Struts. If we were to walk through all of them, it would take most of the webinar, but the one that we're going to run today is actually just a header injection where the actual Java server parses a header incorrectly, and what we end up with is a shell code injection. So provided that we're successful here in our demo, you should actually be able to see that shell code inject into the container environment and then just dump out all the environment variables. So did you want to run the exploit, Laurent?
Yeah, let's go into and see what's going on with the app itself.
All right.
Share here.
I'm just going to change the presenter here. Wow, when there's a lot of people in the webinar, it actually lets me pass the share to any attendee. But I'll go ahead and make sure I pass it to Laurent.
I got it. There we go. All right, so as Andrew showed you, we are going to exploit this app. So what I'd probably do, what you do, kind of like natively, is probably look at the app not from the runtime perspective, right? You want to look at what's happening with the app itself. So I called it Java Goof. This is how I saved it to my account. You can see I have a couple of projects that are monitoring it from the CLI. So I can go to the CLI over here, run a sneak test. We even support this reachable tag, which allows us to figure out if a function is actually making use of a vulnerable dependency. So this helps you kind of like prioritize vulnerabilities. So it's not just hundreds of vulnerabilities impacting the app, but actually some of them are actually callable from the code. So we take some we actually go ahead and do a bit of like annotation to say something is reachable. So you can see it from the CLI, but also then I actually put it in the UI itself. So we have a couple of things where we see that. So first of all, this is basically me kind of monitoring the app from the CLI and sending it here into the UI, and you can see Struts is vulnerable, right? And we have some data here that helps us figure out the prioritization of how to fix it. So we can see that it's not just vulnerable, but there's actually a mature exploiter. So it really bumps up the score and says, hey, this is something that people might weaponize, right? Might use a script and exploit in the wild to basically go ahead and run it for your server. So it says exactly where it's coming from and how to fix it and so on. You can see fixes. You can see if something is potentially reachable or it's actually reachable from code. You can, of course, filter and so on, and then use that to prioritize what's going on. If you don't just use it from the CLI, but actually connect it to your source code management, like we have, if I connected that to GitHub, which I did here, I can actually open a fix pull request, right? So this happens automatically, or I could go and do it manually, like I saved it here to show you how it's done. But basically, this allows us to remediate the vulnerability. Now let's talk a little bit about this vulnerability. So we see the app here, right? We see what's going on, but as developers, we might want to have, grasp a deeper view of what's going on with our applications, because it is based on open source dependencies. So this tree here, I mean, the issue is 57 issues. That's a lot to go through, but it's a nice input. Dependencies, this dependency tree view allows us to also understand better where vulnerability is coming from, like which dependency is the culprit, what should I actually upgrade, and so on. Which brings me to that next issue, right? It's, as developers, we actually want to remediate the problem. We want to fix it as fast as possible and move fast, right? So this remediation tab now helps me understand how to actually fix the problem, right? Not just getting a report of, I have 500 issues, how do I fix them? So for example, by upgrading Struts here, Struts 2 from one version to the other, I'm actually remediating a lot of issues. Some of them, one in particular, is the one that Andrew mentioned before. Let's go to that one, because that's the exploit that exists, and it's an interesting one. Let's see if I can find it really quick.
This is all the standard Snyk workflow, right? So this is just like the Snyk out of the box. It's got the CLI that you just sort of showed very quickly, and this is the Snyk side of the web UI.
Exactly. This is all there. Just import your app, whether it's an open source private project, then you can get started with this. It's as we said in the beginning, free to start with, both this and Datadog, so you can go ahead and experiment with your own projects for this. And I'm going to pick this one. This is the famous one. We're going to see why it was so famous in a second. But this is the Apache Struts. So if you're using Struts, which is very popular web application server for Java, this version was vulnerable. We can see why it was vulnerable. If I open that issue, I've already got it here set for us. This is basically, you see it has like a 10 score, right? Like it's a network issue, a lot of issues around it. Sorry, a lot of the CVSS attributes are really high and bringing basically the score high, but not really just that, but they're exploiting the WAS. I can actually open up references to exploits and POCs, basically proof of concept scripts that anyone can just use and weaponize. Now, let's talk about this for a second. I'm going to go here to the slide after going through all of that you're going to have later. Basically, what we started with before, and we're like open, right, with this, CVE 2017-5638. That's the most popular, I think, CVE. Maybe not after SolarWinds or whatever, but this has definitely been the right. This has been what has been impacting Equifax, and it did that for for a reason. So what exactly happened there? It caused 150 million people, more than that, basically to have their data exposed. But why did it cause it, right? Because of that Apache Struts vulnerability that existed on a server. And if you think about it, why did it happen? Why did that Struts vulnerability really happen? Basically because there was a vulnerability and then a CVE. But once the CVE is out and it's live, people know about it. So that's now a publicly known vulnerability. So people can actually turn that into a proof of concept and an actual exploit that runs. And indeed, as we're seeing in this picture, right, showing the timeline, the distribution from one of the reports that covered the attack and all the information around it, showing you the distribution of time where just shortly after the CVE was known, this vulnerability was made in the wild, attacks started happening on servers, basically exploiting and weaponizing this. So from something like this, a report of a CVE that looks, very, very kind of like, it's I don't want to say dry and boring, right? There's no boring vulnerabilities, but we have a lot of vulnerabilities. A lot of them could be very high, a 9 score, a 10 arbitrary code execution. It sounds really important, but you're not really sure if it's impacting your app. Well, now we're going to see how it's not only impacting an app, we're actually going to find out about it in production, and that's with the runtime. That's where I'm actually going to go here and share with you the exploit itself. So in this exploit directory, which again, like Andrew said, this is all open source. You can go to the webinar. We'll share the resources with you with a slide so you can experiment it and run this practices internally if you wanted to like demo it internally. So we have this. Why does all of this happen, right? The struts vulnerability. Let me put here exploit headers that I show you why. Basically, this is related to this. I'm not a Java person here myself either. Just to put things in perspective, but this is basically a way called OGNL, right? This is the object graph navigation library that exists within Java, within this ecosystem that allows you to basically express if you need to get or set values within the app itself, within the code. So what we're seeing here is obviously no one understands or knows what this content type is, right? This is not a valid content type per se, but it is something that if we reply back with as a header to in a request, the app, the Struts app, actually parses it, understands this is an OGNL notation, and does something with it. What it does is it actually, as you can see here, we're setting a CMD, a command, any command that we want to run as a parameter. You can see the way that we actually concatenate it. We then create a process builder out of it and redirect an error stream. So we're actually able not just to run the command, but actually whatever the command of this process is doing, whatever the output is, the std out or the error stream, actually able to echo back as a response. So this whole thing is something that exists within, that's made possible within OGNL, within Apache Struts itself. Let me go ahead and run this. I'll show you, I think I've already exported this. Is basically I'm running up, don't do anything wild with this. This is now a live demo. So you can see that I've actually exported this out. And I have this, let me show you what's inside it. It's just a small shell script that basically uses that environment variable. And we simply use set here to replace this command as a regex thing, wildcard with just the environment. We just want to print what's running on the environment of this app, wherever it's running, as a function, as a container, wherever it's getting deployed. So let's see. I'm going to run it now, and look at that. Basically, this sent a request to this running server that Andrew, set up on the cloud. It sent this content type. And then the server replied back with the environment variable data on the running server. So this is exactly that Equifax issue, that popular Struts vulnerability that we've seen happening in the wild. And this is a vulnerable Struts version that is, showing us exactly this happening. Andrew, are you seeing anything on your systems? If I pass it back to you, can we see something in the monitoring?
Yeah, I imagine now we'll be able to actually see something on the Datadog side of things, but that was very cool. It's always cool every time I see arbitrary code execution inside of a container that's running in Fargate, right? Because we could do all kinds of things from there. Right. Once we have arbitrary code execution, we could pivot to AWS credentials. We could do pretty much anything we want inside the environment. So
I like thinking about remote reverse shells. That's always handy.
Yeah, and let's go see what it looks like inside of Datadog, and then we'll just talk about all of the open source glue that sort of puts it all together so that Datadog can sort of unify this view of this great data that we have from Snyk with these profiles. So this is the Datadog interface for the continuous profiler. If you've never seen it before, it's under the APM product family. So we have traces and profiles in here. So this is the profiling screen itself, and you can see we have lots of profiles coming in from the Java Goof app. If you're already a customer of Datadog, the way this knows what service a given Docker container or application is associated with is through our unified tagging standard, which is just a way for us to commonly identify components using key values. So this is a specific version of the Java Goof app. If we refresh here, we might see that attack that just came in. If you scroll all the way down in the facets on the left, you'll see one that is called vulnerability metrics, and they're all high severity. There's none in the time window I'm looking at right now, so we may still be waiting for telemetry from that last set of attacks to be delivered. But if we broaden the time window a little bit here, we've been exploiting this fairly consistently and we see that we have a few critical findings here. So these are all traces that are associated with a known vulnerability, and we can see that over here as well. So if you're already a customer of Datadog, you'll see this vulnerability severity information, and it just won't have categories. And as soon as you configure the Snyk integration, that starts to light up, and it starts to give you data on what code paths in the app are actually getting hit that map to those vulnerabilities. So we can pop this out. This is far and away the most beautiful view of a Java stack trace or a Java profile I've ever seen because it's so colorful. It's also actually incredibly useful. Like, not even putting the security information totally aside, this layout is an awesome layout where you can already see what was the slowest method call in here, what were the other methods that were called as part of this profile. Of course, we could do all the regular things that you would expect to do with a profile, like get more telemetry on performance. But our first indicator that this has been decorated with security information is up here at the tippy top, which is that triangle that says detected arbitrary code execution vulnerability. And if we switch to the analysis tab, we actually see that same data, right, that you were showing in the Snyk web interface.
Yep, getting pulled here.
Yeah,
nice how it's handled.
And we can jump to that. We can see the very same vuln information that's from Snyk's vulnerability database just by clicking there. But what this tells us that's cooler than anything is that we have a vulnerability in the product. Snyk knows about the vulnerability, and we are confident that that vulnerability was used in this environment.
Yep.
And that's such a useful thing for a security engineer or an analyst or a forensics person to be able to know in the event of an incident, but it also just helps with development and triage and saves a ton of time.
Yeah, in the world of having so many vulnerabilities, and I think we're going to get at that to the end of the slides, this is answering that concerning issue of how do you triage, how do you actually like prioritize what to fix first. So seeing those vulnerabilities actually hitting your code, that's actually callable from real world behavior, that really helps you go ahead and put the vulnerability triage first.
Yep.
So Andrew, I want to show something that I haven't noticed here. Do you want to set change presenter over to my end? Because I know that I exploited and showed how we're getting environment information, right? But I remember when you configured the app itself, so this is basically me running it. When you configured the app, we basically downloaded the Datadog agent and running it on the container. So I know it's there, I know it needs an API key or something, and I see that this environment running on AWS where you provision this. I see some Datadog information, but I don't see the Datadog API. So that we haven't been able, to exploit Struts itself and running whatever commands we want on this container. We don't see specifically the Datadog API tags or anything else. Why is that happening?
Yeah, that's a benefit of running the sidecar pattern, right? Which is that we have a complete separation of concerns in the app itself for who owns the API keys for Datadog, which is very, very cool because that means just by virtue of the fact that our application itself had a vulnerability that was exploitable, we didn't end up leaking the Datadog API key. And of course, maybe we would have rethought our demo if we're going to show everyone the Datadog API key. But this is one of those cases where we've sort of applied the learnings from the industry around containers into a reproducible blueprint for the way that you use Datadog in a container environment. So that's great.
Pretty cool best practice.
Yeah, I was very surprised at how easy it was as well to deploy the sidecar, and everything just kind of spun up, and I started getting these beautiful traces. Not having touched really Tomcat instrumentation in a number of years, this was so simple to get going. So nice. Very, very, very cool all the way around. And before we go on, we kind of talk about the set, like kind of the supply chain problem here. I just want to take a quick minute and talk about how we stitch the actual integration itself together. Because if you're If you're attending and you're thinking to yourself, wow, this is really, really interesting, compelling technology, how do I go try it out? The simplest way to try it out is actually to use the GitHub action that we partnered up on. So Datadog and Snyk have worked together to create an action for GitHub's built-in CI pipeline. So if you're familiar with GitHub Actions, you might know that you just place a .github folder in your repository, and then you can configure secrets for that workflow, and you can also configure triggers in CI that will run that action. So we have our Datadog Snyk action here. This is almost identical to the one that's in production today. I had to add Maven support to it. The current action supports Gradle primarily, but you can just add very quickly the JDK and you get Maven support, or I imagine this would work the same for Ant because everything is built on standards. So that's great. And then all we're doing is we're telling it to parse this build file. And this is a multi-service Java app with a single pom.xml, but it refers to all those other subsequent POM XML files in all of the other services that are part of this Struts app. So this knows how to do the right thing every time we do a commit. And what it's running a shell script that runs the Snyk CLI, and it produces that vulnerability graph that we looked at earlier in the webinar. Then it posts that vulnerability graph to Datadog, and the way that we know how to associate that data with the right profiles is once again from that unified tagging, which is the service information and the application version. So that's a very long way of saying this is very easy to put together, not much configuration. And then the result is that you have these GitHub actions that just run and update that vulnerability information in Datadog using Snyk every time you commit. So you can see this is the actual action itself, running each of the steps and posting that data up to Datadog so it knows how to correlate the traces.
Basically, every time I run my CI to deploy something, I'm going to get an accurate kind of depths and their callable function vulnerabilities pushed over to Datadog so I can see that in runtime as well, not just in my code.
Yep, a snapshot in time of what the dependency graph and vulnerability information look like for the app. And if that's associated with a deploy and you can pin that version all the way through using that tag model, that's just going to provide more and more powerful information and controls around the vulnerability data as your app kind of goes through its natural life.
It's pretty cool.
It's very cool. So that kind of is the quick explanation of how the GitHub action works. So now let's just, I'm going to turn it over to Laurent here to kind of just talk about the supply chain problem really that exists. We have this statement that comes up over and over in the presentation, which is everybody's really one vulnerability away from being the next major data breach. In this case, we're sort of playing off the Struts exploit, which was made most famous by Equifax, but I'm sure there's a little bit more to that there. So let me just switch back to the slide deck here and keep those questions coming if you have questions for us at the end.
Oh yeah, for sure. All right, so I mean, as we've seen through the demo, through the exploitation, through Andrew's kind of like taking us on this tour of Datadog and how we see it there, right? Where that Equifax breach, right, could have been, you know, easily the most costly in human history. There's so many reports around it. But one of the things that have really, I think, shone through is really how this has been something that, you know, if there was someone responsible for security, right? If there was someone who'd be, you know, triaging, looking at these vulnerabilities as part of a supply chain security ecosystem, had looked at it. This is something that could have been prevented, and I think that's the most important thing that we can take from this story, right? It's the fact that most of these things, you know, could have been prevented, and who is there to prevent them? Is this Is this perhaps developers? Is it security? It's, some people would say it's everyone's job, or it's kind of depends on the culture and whatever you have in your organization. But ultimately, I think what happens is developers are somewhat entitled / empowered to fix the security issues, right? The security departments usually find issues, or DevOps, or so on. But the easy fix, the actual, the upgrades, all of those things usually come from developers. They operate the app themselves. So I think, Andrew, this kind of like takes us a few slides into further into kind of like talking about what is this value here, right? And
Yeah.
whether you are, this is from a chart from the State of Open Source Security report that we've did a couple of years back. Snyk does that annually, so we kind of collect this information, and we're seeing developers, as not there's a reason why we're a developer-first company, right? The developers are really that mitigation point of really empowering someone to fix the issues. But again, this makes us. Go ahead.
A lot of this technology is just about visibility, right? It's about trying to put the problems in front of the development team, because I don't know where you stand, but I would generally say that most developers want to be security conscious and they want to do the right thing for their application, but oftentimes they don't have the data to understand what the right thing is to do.
Yeah, very true.
So let's talk about user value here. I think that this is the last major section we have to get through, and then we'll take questions.
Yeah. So I'm going to give you, I think, a couple of my take. I'd love to hear what Andrew's take on this. But basically, I think this, in an ideal world, what we would want is for developers, as they operate an infrastructure, things like, looking at Datadog, we want to give them the tools to basically, make security visible, right? Make it right there, just like Andrew said, and we want to make it actionable. So we're basically, I think, moving towards a world where security testing, even responsibility for production operations is actually shifting left to the developers and helping them better prioritize vulnerabilities, kind of like developers owning the code, and DevOps kind of creates the infrastructure, but developers, end up maybe operating this infrastructure, right? Maybe altering a Docker file and adding, some components into it to run the app. But at that point, that kind of like leaves the ship and gets moving on to getting orchestrated and so on. So basically shifting left and augmenting this data has this ability to kind of like move traditional analysis from, from the SCA space into this runtime to basically distinguish this signal of, a lot of vulnerabilities, but what is actually in my runtime from the noise itself of, drowning in an ocean of vulnerabilities. You're not really sure what is impacting your app, what is not. So this is basically our take on prioritizing security, but doing it in a smart way.
Yeah, I think you hit on kind of all of the real user value that I think of as well when I think of this integration. But I also think that this is very cool because it's not a pure shift left security measure. So there's been this great movement to shift left, but that's just one of the tools that we have in what we think of as DevSecOps. And there seems to be a belief that if we just do enough shifting left, we will prevent problems from ever getting to production. But with the Snyk integration and Datadog's continuous profiling, what we really have is the best of both worlds, because we are trusting that the right things are happening in CI and that those PRs are being made and the vulnerabilities are being remediated and triaged appropriately. But then we're also validating that by the time the code gets to production, which really leans into a theme I think is going to be really popular over the next year or so, which is verifying that your production exists as you believe it should. So no one's ever made a deploy outside of CI/CD, or no one's ever made a change outside of Terraform, because that never happens. But creating systems that allow us to understand that environment is the same as staging, as development, as local. That's the biggest value for me.
Sounds like we could have said DevSecOps here quite a bit.
Yeah, I was trying to avoid too much branding, because I think this also this technology integration, it crosses a domain boundary, because it's not really purely useful for developers and it's not purely useful for security folks. So we're really seeing like kind of tearing down some of the walls that existed in making this information visible and easier to work with in more places.
Yep.
And I mean, it's not just, we like to say these things a lot, like DevSecOps, break down silos, etc. But this is a tangible, like you can use it today, example of some technology that really lets you do that.
So Andrew, how can we use it? Do we have a slide on resources and
we do.
Getting started with this?
We have some follow-up links here, which we're going to send out. Once again, everything is linked in the slide deck itself. So once again, there's some great engineering blogs linked here in the slide from both Datadog and Snyk. We hand selected these sort of to be complementary to the talk. I went ahead and threw in there a blog post on how our Python profiler works as well, because I think it's a great walkthrough just of how profiling works in languages besides Java. But other than that, there's that GitHub action. The Datadog profiler source code, of course, is open source. And of course, you can reach out to us at Datadog during our community office hours for any of the help you need, which just members of the community team, which is the team that I work in. They help customers with really anything they need if they just join a regular Zoom and ask questions. If they can't help, they find the right resource to help get things going. So no excuse not to just take it for a spin, especially if you have Java in production right now. I would pay serious attention to this.
Yeah, it sounds like there's a lot of resources to just get started with. I love the office hours. If there's anything anyone has a question with, I mean, that's a really great way to just go to that place and just get some help to get started with all of this integration. If you're having any issues, although as Andrew said, also the Datadog app that we just saw with the GitHub action configuration with the Docker file, it's all open source. You can just get it, get it started, look at it, see what you need, and yeah, start deploying it and practice it.
But you can also you can tweet at us. You can tweet at myself or Laurent. Send us DMs. If you have any feedback or questions or you have trouble. I know one of the greatest compliments after one of these presentations is somebody tries to go and use something that I showed during the presentation.
For sure.
So with that, if there's nothing else, I think we're ready to transition to our Q&A section. Almost right on time.
All right. Yeah. Look at that. Okay, we've gotten some great questions in, but there's plenty of time. If you have a question for either Andrew or Laurent, go ahead and use your GoToWebinar control panel and submit it. Let's go ahead and dive into the ones we've gotten so far. Let's see, here's one for you. How do you instrument code to profile through so many variations in languages and library bases, especially language environments being so different at runtime?
That is an awesome question that I don't know that I can answer comprehensively, but I can tell you that a great place to start if you want to understand just some of the challenges in building a profiler for different language runtimes. It's that Datadog engineering blog on how we built the Python profiler, which is quite a bit different than the Java profiler, right? So if you think about the two ways that those languages execute, right? In the case of the JVM, you have the JVM, and it has sort of like an intermediate language prior to becoming bytecode, and there's lots of different languages implemented on the JVM. So there's lots of good checkpoints to be able to kind of insert things like profiling facilities by just patching the way the language runtime itself works. So Datadog just built on top of the standard that really already exists in the JVM. Similar story would be for C#, because C# is also a language runtime that has an intermediate language layer, and you can write, for example, Iron Python on top of the .NET runtime, and it will compile the same way that regular C# compiles. So lots of opportunities there, but in the case of our Python profiler, we had to write quite a bit of CPython binding in order to be able to profile the way that things are executing on top of the Python runtime itself. So it's there's no easy way forward, I guess.
Yeah.
There's good
well,
reading
at
on
least that gives them a flavor. Yeah.
Yeah.
All right, great. Next question, is Snyk also a static code analysis tool, or does it just find open source vulnerabilities in frameworks / dependencies and containers?
A great question. So we actually just announced this, and Snyk does have a static code analysis facet to it. So that's going to be something that is kind of like helping you as a developer in your IDE, finding vulnerabilities as you code, getting recommendations of how to fix it, what's going on there, why is it happening, the path of a source to a sink, and all of that. So that is definitely that's definitely in there. Just visit the Snyk website and check it out.
Okay. All right. Next question. For the exploit demo, was there an alert in Datadog for the exploit based on execution time or anomalous response, etc., that then you could see the app was also vulnerable in Snyk or whatever?
So we did not have an alert that we showed in the demo today, though that would have been possible with another product family inside the Datadog platform, which is our security signals product. And that works in a little different way than the profiler feature. So we saw the decorated trace in the profiler. We would have been able to set up similar detections, in this case for the struts exploit, using the logged headers. So we could have had another trust but verify there. I don't know that you really need anomaly detection in this case to detect this kind of exploit, because the response time would have wavered a little bit, but what we really are seeing here is that if we had header logging, like basic HTTP header logging, we could have hit on that relative to mapping that back to an indicator of compromise.
Excellent. Okay. All right. So go ahead. Sorry.
I was going to say, let me know if there's a follow-up on that or anything else about security signals. That's the product I probably have worked the most with. So happy to answer any questions about that product as well.
All right. All right, great. So we are about 8 minutes to the top of the hour. I think we have time for maybe 2-3 more questions. So go ahead, and if you got a question for either Andrew or Laurent, please go ahead and use your GoToWebinar control panel. Next question, how does this integration show vulnerabilities that are not actively being exploited?
Right, so we basically understand what is callable, right? So Snyk, when Snyk maintains the database metadata, it's not just the vulnerabilities themselves. We actually understand which method of a vulnerable dependency is that component that is vulnerable. It's not just this dependency in that version. We have a deeper understanding of exactly which method is vulnerable. So whether this is actively exploited or this is just callable, we still send all of that data over to Datadog, and then at that point you can see it, whether someone is sending in a request or this, that is actually exploiting it, like we actually did. We weaponized an exploit to do it. Or maybe it's just a request, its content type is just as regular thing, but it did hit a dependency that is callable from the app code. So that's one way to see it. The other way of seeing it, and that is on the shift left part to it at least, is on the UI of the Snyk app, or if you get from the Snyk app, kind of like the bot, you get like GitHub requests for a pull request that kind of tells you, hey, there's a vulnerable method here, and it's also reachable, right? We enrich this metadata in the pull requests and in issues that we open and so on. And so that's one way of doing it, or the Snyk UI. So there's different ways where you could actually see this metadata coming in, all the way from the developer perspective and into the runtime.
Excellent. Okay. Next question here. Regarding static code analysis in Snyk, is it only an IDE-based option right now or replacement for a centralized SAST tool?
It's tricky questions, and this is getting announced. I don't wanna ruin any surprises, but contact us for more information on this. But this is definitely a comprehensive solution. It's not only IDE based, and you could expect a lot from this. But yes, stay tuned and just leave an email or something on the website. There's a lot coming in on this.
Okay. All right. Great.
Hope I didn't steal any thunder for our marketing team here.
I can't wait to see what it looks like, because we've been talking about dynamic analysis all day, right? Because profiling is dynamic analysis, and then we have our shift left tool. So if we had a static analysis component to add to that, we'd have a full AppSec risk mitigation pipeline. Not to use too many buzzwords there, but that's the whole thing: dynamic plus static plus our vuln database.
All right, well, we are 4 minutes to the top. Let's do one more question, then we'll close things out. Can Snyk ID vulnerabilities not publicly disclosed?
It's a really good question. So one of Snyk's strengths is definitely the database itself. That is something that is kind of unrivaled to in terms of the way that we do it. So we are not only, and getting data from public resources that like NVD and CVEs and officials like that. And there's not only we don't only just do the security research itself, which we do, but also what I think is really the answer to that question is we have a way to actually kind of listen and get information and signals about vulnerabilities before they actually turn into a vulnerability, right? So think about an open source project, React, Angular, wherever you're coming from in an ecosystem, that someone's open an issue and, maybe that issue represents an XSS or, fixes a security issue. At that point, Snyk gets all of this data, gets triaged, we actually validate its information. And even before this gets even a CVE or anything official from, anybody, any party that actually responsible to triage this, we actually get and process that internally and make it available. Of course, all of that happens through proper disclosure channels. So this is as close as it gets to finding vulnerabilities before they get truly public through a CVE.
Cool. All right. Great. Well, we're 3 minutes to the top of the hour, so unfortunately that is all the time that we have for the question and answer period. If we did not get to your question, which I know we didn't get to all of them, and I apologize, but please know that the folks at Datadog and Snyk will be getting a copy of all of the questions that came in, and I'm sure they'll be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded, so if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And it's also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, real quick, let's do that big drawing for the 4 $25 Amazon gift cards, and then we'll close things down. Our winners today are not Laron, sorry, no, Jason D. Congratulations, Jason. Our second winner today is Manny V. Congratulations, Manny. Third winner today is Shelby G. Congratulations, Shelby. And our final winner today is Nate B. Congratulations, Nate. We'll be following up with all 4 of you by email to get your Amazon gift cards over to you. So please check your inbox, and if you don't see anything there, just check that spam folder. Okay, Laron and Andrew, great presentation. Love the demo. Awesome technology. You guys have got it going on. So thank you so much for your time and your expertise. I really appreciate it. And judging from the questions that came in from the audience, they dug it too. So good stuff. Thanks so much. Appreciate it.
Thank you, Charlene.
Thank you so much.
I also want to
Thank you.
thank the audience. Yes. I want to thank the audience for joining me today, as do Laurent and Andrew. So this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.